how are you? In this video on the chapter Some Applications of Trigonometry, we will be discussing a question which says two poles of equal heights are standing opposite each other on either side of the road, which is 80 meters wide. From a point between them on the road, the angles of elevation of the top of the poles are 60 degrees and 30 degrees respectively. Find the height of the poles and the distance of the point from the poles. So the question talks about two poles whose heights are given equal. So first pole is AB and another pole is CD. AB is equals to CD because their heights are given equal. They are standing opposite to each other on the either side of the road. So BD represents the road which is 80 meters wide. From a point between them on the road, let O be our point on the road. The angles of elevation of top of the poles are 60 degrees and 30 degrees. So when we observe the top of first pole from point O, the angle of elevation is 60 degrees. And when we observe the top of second pole, that is point C, from point O, the angle of elevation is given to be 30 degrees. We have to find the height of the poles, that is we can find AB or CD, and the distance of the point from the poles, that is distance of point O from first pole, that is OB, and distance of point O from second pole, that is OD. So we can see two right angle triangles, triangle ABO and triangle CDO, right angled at B and D respectively. AB and CD represent the height of the poles and BD represents the distance between them, which is given to be 80 meters. We are also given with angles of elevation as angle AOC. Angle AOB is 60 degrees and angle COD is 30 degrees. We have to find AB or CD, which is the height of the poles, which is given equal, and OB, that is the distance of first pole from point O, and OD, that is the distance of second pole from point O. So starting with the solution, we can see that in our figure BD is equals to OB plus OD. Now the measure of BD is 80 meters. We will consider the measure of OB to be x meters. Putting the values, we will get 80 is equals to x plus OD because BD is 80 meters and OB is x meters. We will get OD as 80 minus x meters. This is our first equation. Now, when we find out x, we can easily find out the value of OD. For finding x, we need to find OB. So, we will be considering one triangle at a time. This is our reference figure. Now, we will be considering triangle ABO first, and we will derive a relationship between height and base, that is perpendicular and base, AB and OB. So, the two trigonometric ratios that involve perpendicular and base are cot and tan. We can use either of them. Here we are using tan theta is equals to perpendicular by base. We are talking about triangle ABO. Here theta is 60 degrees. Perpendicular is AB, which represents the height of first pole, and base is OB, which we have considered to be x meters. Now, putting the values of theta, perpendicular and base here, we will get tan 60 degrees is equals to AB by OB. The value of tan 60 degrees is root 3 and OB is equals to x. We will get root 3 is equals to AB by x. On cross multiplying, we will get root 3x is equals to AB as our second equation. Now we have got a relationship between AB and x. Now we will follow the same steps for other triangle. Here also we will use the trigonometric ratio tan. Tan phi is equals to perpendicular by base. We have used the notation phi for representing the angle because the angle is changing. Initially we used theta for 60 degrees. So we have used phi for 30 degrees. We are talking about triangle CDO. Here phi is 30 degrees. Perpendicular is CD and base is OD, which is 80 minus x according to our first equation. Now putting the values, this is our reference figure. When we put the values, we will get tan 30 degrees is equals to CD by OD. Now the value of tan 30 degrees is 1 by root 3 and OD is 80 minus x. We will get 1 by root 3 is equals to CD by 80 minus x. we will get CD as 80 minus x by root 3 as our third equation. Now, from our second and third equation, we can see that the right hand side is AB and CD. Since AB is equals to CD, which is given, that is the height of the two poles is given equal, and the right hand side of second equation is AB and the right hand side of third equation is CD. And since both are equal, so their left hand sides will also be equal. From equation second and third, we will equate their left hand sides as root 3x is equals to 80 minus x by root 3, where root 3x is the left hand side of second equation and 80 minus x by root 3 is the left hand side of third equation. On cross multiplying, this root 3 will get multiplied to root 3x. We will get 3x is equals to 80 minus x. On rearranging, we will get 4x is equals to 80. X comes out to be 80 by 4, which is 20 meters. Now we have got the distance of point O from first pole, that is OB, which we consider to be x meters as 20 meters. Now from equation first, we can find out OD. The value of OD is 80 minus x meters. We have found out the value of x as 20 meters. Putting the values, we will get OD is equals to 80 minus 20 meters. OD comes out to be 60 meters. We have found out the value, found out the distance of point O from both the poles. Now we have to find out the height of the tower. So now that we have the value of x, we can put it in either second equation or third equation to find out the value of AB and CD, which will be equal because it is given that AB is equals to CD. So using equation second, which is root 3x is equals to AB, the value of x is 20 meters. Putting the value, we will get AB is equals to 20 root 3 meters. And since AB and CD are equal, so CD will also be equal to 20 root 3 meters. Let's report our answer. Hence, the height of the poles is 20 root 3 meters and the distance of first and second pole from point O is 20 meters and 60 meters respectively. This sums up our question. Thank you for watching the video.